Hello, so today I'll be talking about the 2014 AP Calculus BC FRQ question number 2, and it reads, the graphs of the polar curves r equals 3 and r equals 3 minus 2 sine 2 theta are shown in the figure above for 0 is less than or equal to theta, which is less than or equal to pi. And part A asks you to find the region that is inside both curves. So we can see from this graph that they give you that it is made up of a quarter circle and then the area under r equals 3 minus 2 sine 2 theta in the first quadrant. So let's start with that first quarter circle. We know that the formula for a quarter circle is pi r squared over 4, and we know that r equals 3, so we can just find out that that area of the quarter circle is 9 pi over 4. And to find the area in that first quadrant under r equals 3 minus 2 sine 2 theta, we know that the area for polar curves is 1/2 of the integral from a to b of r squared d theta. And what I like to do, instead of doing that 1/2, because sometimes you might forget that, I like to multiply 1/2 of the area by 2. So you can see by symmetry that this section here is the same area as this section here. So if we take the integral from 0 to pi over 4, instead of taking the integral from 0 to pi over 2 of just this area, then we don't have to have that 1/2 out front because we can just multiply it by 2. So let's say that you weren't convinced that this is pi over 4 because you, I don't know, didn't see it or just want to be definitely sure, then you can use your graphing calculator to find that out. So I'm going to graph the curve r equals 3 minus 2 sine 2 theta, but not using polar. Instead, I'm going to switch it to function. And this is because they already give you the polar curve, and I want to be able to calculate when the theta is equal to this part right here. So I'm going to graph it on function, and I already set the interval of x from 0 to pi because that's what the interval they give you here. And we can see from the side-by-side comparisons of this graph that this part here, this theta that I want to find, is going to be this minimum of my graph. So I can calculate my minimum, and I'm going to go left bound of my minimum, and then right bound of my minimum, guess, and then it tells you that my minimum is at x equals 0.78539. So let's say you didn't want to use decimals, you could just be able to figure out what that would be in terms of pi. So let's say you guess pi over 3, oh, that's not it, then guess pi over 4. Perfect, 0.785. So now we can set up our integral as 2 times 1/2 of the integral from 0 to pi over 4 of our r squared, and that roughly gives us 2.63937. And then don't forget the 9 pi over 4 that we already calculated, so we want to add those two areas, and then our final answer is going to be 9.708. And now for part B, they want you to find the value of dx over d theta at theta equals pi over 6 for the curve r equals 3 minus 2 sine 2 theta. So we know that x is equal to r cosine theta, and in this case it will be 3 minus 2 sine 2 theta times cosine theta. And since they want you to find dx over d theta, you could just use product rule to figure that out, but since we have a calculator, we can just use our calculator to find that. So I'm going to switch my calculator back to polar, because in my polar function I already have that stored, my r stored. So then I can go to math 8, and that's derivative, and do the derivative of my function polar r1. So since I already saved that, I just want to save the trouble of having to input that value of r, and it's r1 times cosine theta, and that's evaluated at theta equals pi over 6. and you get the answer negative 2.366. Part C says the distance between the two curves changes for 0 is less than theta, which is less than pi over 2. Find the rate at which the distance between the two curves is changing with respect to theta when theta is equal to pi over 3. So at first when I read this problem I was kind of confused because I thought that maybe I should use distance formula or something like that. But if you think about the radius as the distance from the origin, I think that really helps. So when we look at this graph for r equals theta, this means that any point on this graph is going to be 3 away from the origin, or anything on the graph of r equals 3 minus 2 sine 2 theta is going to be 3 minus 2 sine 2 theta away from the origin. So if we think about the radius as just distance from the origin, we can think about it as the distance between the two curves is just the outer distance from the origin minus the inner distance from the origin, and that will give us the distance between the two curves. So distance is equal to the outer function, which is 3, minus the inner function, which is 3 minus 2 sine 2 theta. And we can simplify that to the distance is equal to 2 sine 2 theta at any given theta. And then we want to find the derivative of that at theta equals pi over 3. So we can just use our graphing calculator, and that's math 8 evaluated at theta, and that's 2 sine of 2 theta at theta is equal to pi over 3. And that gives us the answer of negative 2. And part D says, a particle is moving along the curve r equals 3 minus 2 sine 2 theta, so that d theta over dt is equal to 3 for all times t is greater than or equal to 0. Find the value of dr over dt at theta equals pi over 6. So I thought that this problem was kind of confusing at first, so let's just think about what we want and what we know. So we want dr over dt, and we know that r equals 3 minus 2 sine 2 theta, dr over d theta is equal to negative 4 cosine 2 theta, and that's just simply taking the derivative. And then we also know that d theta over dt is equal to 3, because that's what they give us. So if you sort of just think about it, dr over dt is equal to dr over d theta times d theta over dt, because those d thetas will just cancel out and you get dr over dt. And you can sort of just think about that by evaluating what you have and just sort of trying to manipulate that into getting what you want. So you get dr over d theta times 3 is equal to dr over dt, and we can just evaluate dr over d theta at theta equals pi over 6, and you end up getting negative 2 times 3, which is equal to negative 6. And if it's hard for you to think about it in this way of just multiplying those two dr over d theta and d theta over dt together to get dr over dt, because I thought that was pretty confusing at first too, you can think about it sort of parametrically. So in parametrics, dy over dx is just equal to dy over dt over dx over dt. So that's how I sort of thought about it too in polar. So dr over d theta is equal to dr over dt over d theta over dt. And then we can, since we want to find what dr over dt is, we can just multiply these two together, and that gives us that dr over dt is equal to dr over d theta times d theta over dt. And that gives us the exact same thing that we had here. So if this is an easier way for you to understand it, just sort of parametrically, then go for it. And if not, you can just sort of think about it in this whole cross-multiplying type of way, and both work fine. Thanks for watching this video, and if you need any more help, you can go to 2005 number 2, 2007 number 3, and 2013 number 2 for some more practice problems of FRQ questions that are about polar graphs. And also, if you want more help, you can go to the textbook sections 10.3 and 10.4. My textbook is the Calculus Early Transcendental 6th edition, so if you go there, you can find some more help about polar. Thank you for watching this video, and hope you have a great time studying.